What's going on, everybody? Today we're going to be comparing DuckDB versus QuestDB versus TimescaleDB versus just flat Parquet files to see what the best time series database is. So I've made all these different functions and they all have different results. I just came up with this because it was for my own use case and I needed to see what the best and fastest methods were. So obviously each one's going to be performed separately, so it's a good benchmark. And without further ado, well, first, our data set is 5 million rows long and takes about half a gigabyte up in space. The write took 1 second and the read took less than a second. So Parquet files, it's obviously going to be pretty hard to beat compared to having an actual database and running in Docker. So first up, let's do QuestDB. QuestDB has two different methods. Both of them I was able to find online. This second one is super slow, so I'm not even actually going to run it. You can run it yourself in the description. There's a link to this code, but just for the sake of brevity, it takes too long, so we're just going to run the first one because it just takes a ridiculous amount of time, honestly. Okay, so it ended up taking 7 seconds to write and 16 seconds to read. Again, obviously going to be slower than the Parquet, but still not too terrible. If this was a little bit bigger, maybe 3 or 4 times the current size, yeah, it might start becoming a problem. But for now, it's fine. So next, let's do DuckDB. And yeah, it's already done. It's under 1 second write, under 1 second read. Super fast. I love DuckDB. I use it every day. It's not your typical database. It's literally just a file. So it's not running on any kind of server. With that comes the fact that you can only do concurrent read-only connections. You can't do concurrent write connections. So if you want to do a write operation on your Duck database, you have to close all other connections before you do it. But if you want to do reading, then you can just have as many connections as you want. That's basically the only downside. If you're working locally, I love it. So it's pretty great for speed. So next up, Timescale actually has 3 different methods I was able to find online. 2 of them are very slow, so we're not actually going to run them. Again, the code's in the description. They're just there for reference, I guess. But yeah, let's see how it fares. Okay, now this one's done. Yeah, so I ended up taking 37 seconds to write, which is really slow, and 15 seconds to read, which is the second slowest. The thing is, I still use TimescaleDB, just not for these massive data sets. I use it only for stuff like earnings and, well, I mean, it's just Postgres. I use Postgres for all these things, fewer than, maybe 1 million rows or something, because then it's much more reasonable in the amount of time it takes to read and write. There's also another one. There's InfluxDB that I didn't test in this, just because it didn't really meet my use case. I didn't have a reason to test it, but I hear that it's pretty much similar to TimescaleDB. Other than that, leave a like if you liked the video. That's pretty much it. Thank you very much. Have a good one.